all relative frequency is the percentage of the total. So in this case, in this first problem, problem 2-51, it wants you to use relative frequency to determine what percentage of each of the participants answered good, horrible, okay, or outstanding. It doesn't have any outstanding, so in order for us to use the pivot table version, which makes it a little bit easier, we have to add in the outstanding and just put 0, so it doesn't count it. Pivot tables are a really useful tool when analyzing data, and it can do a number of different things, but particularly when you have a simple set of data like this. And what I'm going to do, delete that one. So if we go into our insert, the first thing that's available is a pivot table. And it wants us to select the table or range, so we're going to select this section here. And we want to put it in the existing worksheet. And I'm okay with that location, but you can click on any location wherever you want it. And we're going to say OK. So now it gives you some options on how you want this pivot table to work. So the first thing we need is we need to know we need our labels. So we need to know the counts for horrible, okay, good, and outstanding. So we're going to put that in here. And that goes under the row labels. If I wanted something different, I can move this. I can take it out altogether. You can drag it down instead of clicking on it. And then for count, so it automatically goes into values and it automatically gives us a sum. So we can actually relabel this. I just double clicked on that and I can just label this frequency. If we didn't have the count here, we could also use the count function to just count how many of each. So we would drag the responses into values as well and use count. So now I need to know the relative frequency or the percentage of the total. So I'm going to drag my count back down into here. And again, you can double click on it, or you can right click on it, or you can click on this little down arrow to get this value field setting. And this is going to be my relative frequency. And I still want it to sum, but I want to show my value as a percentage of the column total. And now we have relative frequency. So all this is doing the math for us. It's preventing us from having to count 1, 2, 3, 4. It's actually doing it for us. It's doing the count for us, and it's doing the percentage for us. You don't have to use a pivot table to do this. You don't have to submit your homework in a pivot table. And I am recording this too so that you can, if you want to go back and watch how to do the pivot table a few times, this will be available for you. The other way that we can do it is by using just a formula. So in this case, the problem gives us the frequency. So we need to total the frequency because, again, our relative frequency is the percentage of the total. So we total the frequency using sum, so equals sum, and then highlight our data. And then our formula for relative frequency is our frequency divided by the total. These dollar signs are here because that locks down this cell. So anytime we copy a cell in Excel, it will carry the formula down. So you'll notice this one moves, but this one doesn't. You can either manually put in dollar signs, or you can press the F4 key. And depending on, so this one would lock down the row of 9, but if we copied the cell over, it would change the column from B to C to D as we moved over. This one would copy, or would keep the row or the column the same, but it would change our rows as we move down. So if you want to lock it down completely, you just keep hitting F4 until it puts the dollar sign on both. So now we have our relative frequency. We can build a chart or a graph using this table. So we're going to go to Insert, and we can go to Recommended Charts, or we can pick the one. So I know I want a bar chart, and I want this type of bar chart. I don't want the total column in here. So I'm going to format my chart, under Design. And where it says Select Data, I'm going to change my data. And I just want this piece here. And actually, I don't even want my relative frequency. I just want my frequency chart. So I'm going to uncheck relative frequency. I'm going to say OK. And now we have a simple chart in here with our frequency. We can use these icons here to help style the chart. You can also pick a pre-styled one from the designs up here. And in this case, I want labels on it. I want it to say the 328, 257. So I'm going to hit the chart elements, and I'm going to choose data labels. So now I have data labels. And what I don't need is a legend because we only have one item, so I'm going to take that out. And now I have a simple chart in there with some data labels. All right, and I will go through one more. So the other piece for frequency is cumulative frequency, and that's really just the total, the running total. So if you were to do a running total in your checking account, or a running total of people as they attended, for example, it's the same type. So the running total, the first line is always just going to be equals the first one. The second one will be this one plus the total up here. And then we can copy that down, and we can see that it continues to move the formula down for us. So our current one plus the prior total. And your last line should always equal your actual total of frequencies. And then relative cumulative frequency then is the cumulative frequency divided by the total. And again, we locked that down with F4. So we can see that our frequency adds up to 100 as it accumulates. So this helps us because we can take a look at our attendance, and we can say that anything up to 2,000 accounts for 68%. But 1,750 to 2,000 by itself accounts for only 33%. So cumulative frequency allows us to build bigger or smaller groups depending on how we want to look at the information. Any questions on this part? I know I go through it really fast, but I also, that's why I record it too, so that you guys can watch it over and over. But anything I didn't show that you'd like me to show again, or show for chapter 2?
No, I think I got it.
Okay. So for chapter 3, this is where I really encourage using Excel, because doing these formulas for chapter 3 are really cumbersome, particularly if you have to write them out and use a calculator. Excel has pre-built-in formulas for all of these things. So when we're looking at the mean is the average. So we can, the formula for mean for these two stocks, for example, is just equals average. The variance is how much do they vary . And so our variance here, we can use var A. And there's different types of variance formulas in Excel. You'll see that there's var A, there's var P. It just really kind of depends on the data. The example they show in the video uses var P. In this case, for the comparison of the two stocks, you're going to use var A. And sometimes it's a matter of just reading the description in Excel to try to identify which one you need to use. But to help you guys out in this problem, and actually all of the chapter 3 problems, you're going to use the var A. And standard deviation, and let me switch real quick. Maybe. Standard deviation is really looking at where our data falls. So when we're looking at one standard deviation, all of the data in our samples, when this set here, 68% of that falls within one standard deviation. 95% of our data falls within 2 standard deviations. And all of our data, or almost all of our data, falls within 100, or within 3 standard deviations. And so a standard deviation is off of the mean. So what we want to find out is where these points are, plus or minus the mean, to know what data points would fall within one standard deviation. So if we look at this, for example, and we just use this StandDev A formula, our standard deviation is 17.37 for stock A, and the mean is 11.30. So our mean would be here, 11.30, and one standard deviation would be 28.67, and negative one standard deviation then would be negative 6.07. So 68% of the data will fall between those 2 points. The coefficient of variance is a number that we use to determine what the range is from our mean. So it's basically our standard deviation divided by our mean. So once you have those two numbers in, you can calculate the coefficient of variance. The risk-free rate is actually something that the problem gives you. This is the rate that we could alternatively invest in instead of one of these two stocks. And we use that risk-free rate to calculate the Sharpe ratio, which is our mean minus the risk-free rate and divided by our standard deviation. The Sharpe ratio is a statistical measure of risk regarding a particular investment. So what we're looking for is a higher Sharpe ratio. So in this case, stock B would be a better value or a better investment. It also has the lowest standard deviation, which means that there's not a lot of difference. There's not as much difference between the data points, so between the years for stock B as there is for stock A. The more a stock fluctuates, the less it is. It also has the lower variance and the higher mean, so the higher average. So overall, stock B is the safer stock than stock A. But this example spreadsheet that I also posted for you includes all of these formulas for you. These are the formulas that you'll need to do all of Chapter 3. So as long as you stick with these formulas, you should be fine. Any questions on those so far?
No.
I hear kiddos. So the first week, this covers most of the first week. I'm going to go ahead and end the recording.